Welcome back to PrepForge. This is the first of 2 episodes on distributed NoSQL databases. Today, Amazon DynamoDB. Next, Apache Cassandra. They're deeply related. Both descend from Amazon's famous Dynamo paper. So we'll build the core ideas here, and then see how Cassandra does the same things when you run it yourself. Here's the DynamoDB pitch. It's a fully managed, serverless, key value and document database that gives you single-digit millisecond performance at almost any scale, with no servers to run. In this video, we'll cover tables and items, the all-important partition key, how data is spread across partitions, reads and consistency, secondary indexes, capacity, and a few advanced features. Let's get started. Let's start with the problem. A traditional relational database is fantastic until you try to scale it beyond one very large machine. Sharding it across many machines yourself is painful, and joins and complex queries get slow at massive scale. For workloads that need predictable, low-latency access to huge amounts of data, think shopping carts, user sessions, gaming state, you want something that scales horizontally and stays fast no matter how big it gets. And ideally, you don't want to run any database servers at all. DynamoDB is Amazon's answer. It trades away the flexible querying of SQL, and in return gives you near unlimited horizontal scale, single-digit millisecond performance, and 0 servers to manage. Concept 1. What DynamoDB actually is. DynamoDB is a NoSQL database, specifically a key value and document store. There's no fixed schema and no joins. What makes it special is that it's fully managed and serverless. You never provision a server, patch software, or handle replication. AWS does all of that. It automatically stores copies of your data across multiple availability zones for durability, and it delivers single-digit millisecond latency even at enormous scale. Keep in mind, DynamoDB grew out of Amazon's Dynamo paper. In our next episode, Cassandra, you'll see these exact same ideas: partitioning, replication, tunable consistency, but in a database you run and operate yourself. Concept 2. The building blocks, tables, items, and attributes. The structure is simple. A table holds items, and an item is like a row. Each item is just a collection of attributes, which are like columns, key-value pairs. But here's the NoSQL twist. The table has no fixed schema beyond its primary key. 2 items in the same table can have completely different attributes. One order item might have a gift message, another might not. Only the primary key is mandatory. Everything else is flexible. So it's best to picture items as JSON documents, each up to 400 kilobytes, rather than rigid rows in a fixed table. Concept 3. The partition key and sort key, the single most important thing to understand about DynamoDB. Every item is identified by a primary key, and it comes in 2 parts. The first, and mandatory, part is the partition key. Take our orders table, keyed by customer ID. DynamoDB takes the partition key, hashes it, and that hash decides which physical partition the item is stored on. This is the heart of how DynamoDB spreads data and load evenly across machines. The second, optional part is the sort key, for example the order ID. Items that share a partition key are stored together, sorted by the sort key. So all of one customer's orders lie on the same partition, in order. That makes one query: give me all orders for customer 123, extremely fast and cheap. Choosing a good partition key is the most important design decision you make. Concept 4. Partitions and scaling. So how does DynamoDB scale? Data is spread across many partitions, and the partition key's hash decides which one each item lands on. As your data grows or your traffic increases, DynamoDB automatically adds more partitions and redistributes the data behind the scenes. This is horizontal scaling. No single machine ever becomes the bottleneck, which is why it can handle virtually unlimited load. But there's a classic gotcha: the hot-partition. If you pick a partition key that everyone hammers, say, a single value that most reads and writes target, all that traffic hits one partition, and you get throttled while the rest of the table sits idle. The rule: choose a partition key with high cardinality and even access, so load spreads out. Concept 5. Reads and consistency. There are 2 ways to read. A query fetches items by their partition key, and optionally narrows by sort key. It's fast and targeted. It goes straight to the right partition. A scan, by contrast, reads the entire table and filters afterward, which is slow and expensive. You avoid scans in production. Now, consistency. Because DynamoDB keeps multiple copies of your data, a read might hit a copy that hasn't received the very latest write yet. So by default, reads are eventually consistent. They're fast, but might be a split-second stale. If you need the absolute latest value, you request a strongly consistent read, which always reflects the most recent write at a higher cost. That eventual versus strong choice comes straight from the Dynamo lineage, and you'll see it again in Cassandra. Concept 6. Secondary indexes. By default, you can only efficiently query by the primary key, but real apps need to look data up other ways. Say, find all orders with status checked. That's what secondary indexes are for. A global secondary index, or GSI, lets you define a completely different partition key and sort key, effectively a second view of your table you could query independently, and you can add one at any time. A local secondary index, or LSI, keeps the same partition key but gives you an alternative sort key. Indexes cost extra storage and extra write capacity because every write updates them too. So you add indexes deliberately to support the specific access patterns your application actually needs. Concept 7. Capacity and cost. DynamoDB measures throughput in capacity units. Read capacity units, RCUs for reads, and write capacity units, WCUs for writes. You choose between two billing modes. In provision mode, you specify how many RCUs and WCUs you want optionally with auto-scaling, and you pay for that capacity. If you exceed it, requests get throttled. In on-demand mode, you don't plan capacity at all, you simply pay per request, and it scales instantly to whatever your traffic demands. The rule of thumb: use on demand for spiky or unpredictable traffic, and provisioned, which is cheaper, for steady, predictable workloads. Concept 8. A few advanced features worth knowing. A few power features. DynamoDB streams give you a change log of every insert, update, and delete, which you can feed into a Lambda function to trigger workflows or replicate data. Time to live, or TTL, lets you set an expiry timestamp on items so DynamoDB deletes them automatically. Perfect for sessions or temporary data. Global tables replicate your table across multiple regions. Active for global low latency. There's also support for transactions, all or nothing writes across several items. And the advanced pattern experts talk about is single table design, where you cleverly model many different entity types in one table using the key structure to serve complex access patterns with minimal cost. Concept 9. When to use DynamoDB and how it compares to Cassandra. So when should you use DynamoDB? Reach for it when you need massive scale, key-based access patterns, predictable single-digit millisecond latency, and you want zero operational burden, no servers ever. When should you avoid it? If you need complex queries, joins, or ad hoc analytics, a relational database is the better tool, because DynamoDB deliberately gives those up. And if your access patterns are unknown or constantly changing, DynamoDB is hard, because you must design your keys around your queries upfront. Finally, how does it compare to Cassandra, our next episode? They share the same DNA, partitioning by key, replication, tunable consistency. The core difference is operational. DynamoDB is fully managed by AWS, while Cassandra is open source and you run and tune it yourself. Said simply, DynamoDB is scale and speed in exchange for query flexibility and control. Explain the partition key and eventual versus strong consistency, and you've shown you truly understand it. And that's DynamoDB end-to-end, a fully managed key value and document store where the partition key hashes your data across partitions for near unlimited horizontal scale. Reads are eventually consistent by default or strong on request. Secondary indexes open up new query patterns. Capacity is provisioned or on demand, and streams, TTL, and global tables round it out. It's massive scale and speed in exchange for the flexible querying of SQL. In our next episode, we'll take these very same ideas, partitioning, replication, tunable consistency, and see how Apache Cassandra implements them in a database you run yourself. If this helped, subscribe. Cassandra is next. Thanks for watching, and good luck in your interview.